Hello, welcome back again. So we are going to continue proving or verifying trigonometric identities using the fundamental identities that we've already been familiar with, and on page 1 of our notes. So let's look at the this next one, example 5. Looks like the most complicated version of side is again the left-hand side, so we'll start there. All right, so we have, and when we have, everything's in terms of sine and cosine, and they're squares, so it's probably a good thing to use the fundamental identity again. Okay, I'll just remind you what that is. And we can see immediately, since we want to get everything in terms of cosine on this side, let's probably we can replace this sine squared with something, because we know that from here we can see that sine squared will be 1 minus cosine squared. So from here we can say that, make that substitution, and if you remember the parentheses. Okay, and then distribute the minus sign, and then collect like terms. So this will be cosine squared plus cosine squared, so that'll be 2 cosine squared of theta minus 1. And that's exactly what we wanted to show. Okay, let's look at this next one, number 6. So number 6, we are trying to show that the secant theta minus tangent theta is equal to cosine of theta plus over divided by 1 plus sine theta. There are a couple ways we could do this. Again, but because it looks like the most complicated way to do this, or the most complicated thing is side is that the right hand side is, so let's start there. So if we start here, cosine theta over 1 plus sine theta. Okay, now at first it looks like there's not a whole lot we can do right now. We can't break this up, but we can have this trick of sort of quote-unquote rationalizing the denominator by multiplying and dividing by something. And the trick here is, we'd like this to be, if we could make this 1 minus sine squared, that would be great. We can do that if we multiply this by 1 minus sine theta. And if we do that on the bottom, we have to do this on top. Okay. So if we do that, then we get cosine theta times 1 minus sine theta all over 1 minus sine squared theta. Because this is the difference of 2 squares. Okay, maybe I shouldn't call this the conjugation trick, but you have, something in the form of a plus b times a minus b, so you get a squared minus b squared. Of course, 1 squared is 1. Now you can say that 1 minus sine squared of theta, that's cosine squared from the fundamental identity. And you can cancel one of these cosines. So this will be 1 minus sine theta over cosine theta. Okay. And now, because you have 2 terms in the numerator, just 1 term in the denominator, now we can break this up as 1 over cosine theta minus sine theta over cosine theta. And this, of course, is the secant. And this is the tangent. Okay. And I should say, if you wanted to do it the other way, if you wanted to start on the left-hand side, the first thing you would do is write it in this term, and then get a common denominator. So basically you get to go from here to here to here, but then you'd still have to do a little trick of multiplying and dividing by something, in this case the cosine, and then going from there. All right, and yeah, so you have to do a little bit of work here. So there are a couple ways to do this. All right, let's look at example 7. here we're trying, now both sides seem about equally complicated. So let's start on the left-hand side. So the thing here is we can factor out a secant squared. And every time we have a secant squared, that's good, because we can replace a secant squared with 1 plus tangent squared. So let's first write this left-hand side out. Okay, so then this will be secant squared times secant squared of theta minus 1. Okay, that's great. Now we know that secant squared of theta is 1 plus tangent squared theta. So this becomes 1 plus tangent squared. And secant squared of theta minus 1, if we subtract 1 from both sides, we can see that the secant squared of theta minus 1 is tangent squared. So that's what the second factor becomes. And then we can distribute the tangent squared, and we'll get tangent squared times 1 plus tangent squared times tangent squared. That's tangent to the fourth of theta. And we can, of course, rearrange these terms. And that's how we can do that. Okay. Number 8 looks like it's going to be a mess, and it still might be, but let's, we can see that there really isn't any advantage from starting with either the left-hand side or the right-hand side. So I'm just going to start on the left-hand side. And the thing here is there's no nice identity directly relating the tangent to the cotangent other than they're reciprocals of each other. Well, we can actually, let's see if we can do this with breaking everything into sines and cosines. Actually, we could probably, actually do a little trick here, because we know the tangent and the cotangent are reciprocals of each other. If we take 1 plus the tangent of theta, or 1 minus the tangent of theta, we can write this 1 as, well, we can actually factor out this tangent from both sides. Now, how can we do that if there's no tangent here? Well, we can write this 1 as tangent times cotangent. In fact, why don't we, I'm just trying to think what's the best way to do this here. Okay, well, we'll do it maybe 2 ways. So we can write this as, actually, let's just write this in terms of cosine, not sine, cosine. Okay. Now, if we do this, we can kind of simplify the top and bottom by just multiplying both sides by cosine theta. Because then what happens is we distribute this cosine, so we'll have cosine of theta times 1 plus sine theta. So this will be cosine theta plus sine theta. And then down here we'll have cosine theta minus sine theta. Okay. And then what we can do is we can factor out a sine. Now, how can we do that? Well, we haven't, we can factor, there's no sign here, but we can sort of factor out a sign if we use reciprocals. So what we can do is we can write this as sine theta times cosine theta over sine theta plus 1. And do the same thing down here, sine theta times cosine theta over sine theta minus 1. And if we do that now, the signs will cancel, and we'll just get cosine theta over sine theta plus 1 over cosine theta over sine theta minus 1. And this, of course, cosine divided by sine is the cotangent. Okay, which is exactly what we wanted to prove. I think another way you could have done this is, which it might have been a little easier, I don't know. We could have written this as 1 plus tangent theta over 1 minus tangent theta. And if we factor out a tangent in the same way, and then this would be cotangent of theta plus 1 over tangent theta, cotangent of theta minus 1. And then these would be, then you can see the tangents cancel and you just get cotangent of theta plus 1 over cotangent of theta minus 1. So I guess maybe this might be a little bit, maybe a little bit easier. I don't know. Okay, but have to be a little slick about that. Okay, number 9. This is looks like a more complicated version. So I'm going to start over here on the left. And because everything over here is in terms of cosine, or at least there's no sine, it might help to rewrite this sign in terms of cosine, and we know that sine squared is 1 minus cosine squared. So this is going to be 3 times 1 minus cosine squared theta plus 4 cosine squared theta. And then we can distribute the 3. So 3 times 1 is 3 minus 3 cosine squared theta plus 4 cosine squared theta. And you have minus 3 cosine squared plus 4 cosine squared. So this simplifies like terms as just 1 cosine squared. So this is 3 plus cosine squared of theta, okay, which is what we wanted to prove. Okay. For number 10, probably a good idea to write everything. Let's start with the left-hand side. This is more complicated, and let's try to write everything in terms of sine and cosine. Okay, when in doubt, that's always a good way to do that. So the secant of theta is, okay, so let's rewrite the left-hand side first. And then this is going to be, secant is 1 over cosine. Cosecant is 1 over sine. And then we'll keep the second term as is. And for this term, what we can do is this is actually 1 over cosine times sine theta. So this is actually a couple ways you could do this. You can write this as the, here's the numerator of this, the big numerator of this fraction. And then when we divide by 1 over sine theta, that's the same thing as multiplying by sine theta over 1. And then this, of course, will be sine theta over cosine theta plus sine theta over cosine theta. And this is just 2 sine theta over cosine theta, which, of course, is 2 times the tangent of theta, which is what we wanted to show. Right. All right. We'll let you do a few more practice problems, or you can just go to the next video and we'll finish up these notes.